In this video, we're going to start looking at polynomial division. We're going to look at two different approaches. The first is algebraic long division, and the second is equating coefficients. To begin with, this looks quite daunting. All we need to do is get a basic understanding and do lots of practice. So let's start off by looking at dividing polynomials. It says explain whether or not you can use long division to simplify the following fractions. I'm going to introduce a word called degree. When we look at the numerator of this fraction, the degree is 2. That means that we have a quadratic term. It's the highest power of x. We can see in the denominator that the highest power of x is 2. So the degree of the denominator is also 2. We can divide a polynomial of degree m by a polynomial of degree n where m is equal to or greater than n. So what does that mean? Well, let's just look. Let's take this one for example. The degree of the numerator is the same as the denominator, so yes, we can. If we look at this, when we divide, we're going to get a constant term. The reason being, if we have now the degree in the numerator, m, and the degree n in the denominator, when we divide, what we'll have is m minus n. So, quite clearly here, we're going to end up with a degree of 0 or a constant term. Can we use division on this one? Well, the highest power of x in the numerator is 3, or a cubic term. In the denominator is 1. So this now can be divided, as m, the power here, is greater than n. So if you like on this one, m is equal to n, so you're good to go. Here, m is greater than n, so yes, you can. And if we divided these now, we would get a squared term, as it would be 3 minus 1. You don't need to know that as such, but you certainly do need to understand now that with this proper fraction, we're going to end up now being able to divide it. This one here, we can see the degree of the numerator is 2, the degree of the denominator is 3. Therefore, we can't, because in this particular circumstance, or this particular example, n is going to be bigger than m. So, if you're using polynomial long division, or equating coefficients, however you want to do it, we must ensure that the highest power of x in the numerator is at least the size of that in the denominator. So x squared over x squared is fine, x cubed over x is fine, this though is not. So let's go ahead and look at dividing now, and we'll start off with a basic example. We're asked to find the quotient when x cubed plus 2x squared minus 4x plus 1 is divided by x minus 1. The quotient, if we had, for example, let's just say now 8 divided by 2, we know that that is 4. That is the quotient. In that particular case, there is no remainder. If we had 9 divided by 2, then we're going to have 4, and we're going to have now a remainder of 1. So in this particular case, that would be the quotient, and that would be the remainder. In the next example, we will look at the idea of a remainder. So what I'm going to do here is use the first technique. The first technique is called polynomial long division, or algebraic long division. All we do is set up a bus stop, as we would have done lower down the school. We have the x minus 1 on the outside. If you want, you could call this the divisor. Often we don't really need that term, but I think it's important to introduce it. And then we have the dividend, which is this just here. Again, that's a term that you don't necessarily need to know. All you need to know is what we're going to get as the quotient and the remainder. In this particular case, we won't have that. So all I'm going to do is put now the x cubed plus 2x squared minus 4x plus 1. If I have a term missing, so for example, if the x squared term was missing, I would put 0x squared in as a placeholder. That makes my division a lot easier. The technique that you're going to see now, you might need to pause and keep going over it. That's perfectly fine. What we do at this stage is take the leading term of this particular polynomial. Polynomial just being now a term here with multi-terms, if that makes sense, rather than a monomial or a binomial. It's got lots of terms here, and we've got positive powers of x. So one way of looking at this is saying how many x's go into x cubed, or we could say what is x cubed divided by x. Entirely up to you on how you want to think about this. All I'm doing is simply now taking the first term here and seeing how many times it goes in to the first term here. So x cubed divided by x will give me x squared. I place that now in above the line just here, and I start forming my quotient. At this point I multiply down. So all I'm going to do is multiply down. X squared times by x is x cubed. I'm expecting that to be the same as the first term in the dividend. I now multiply down. X squared multiplied by -1 will give me -1x squared. And I keep these in order. What I now do is draw a line underneath and I subtract downwards. This should always give me 0. Plus 2x squared, subtract now this -x squared is going to give me plus 3x squared. I now bring the -4x down and write it like so. At this point I stop. I now say to myself, how many times does x go into 3x squared? Or, if you like, what's 3x squared divided by x? And the answer is going to be plus 3x. It's a plus as we've got a plus sign here. We now go back to multiplying down. So we've got 3x and we multiply that by the x, and that will give us now 3x squared. We expect these terms to be the same, as when we subtract down, we will cancel. We multiply down. 3x multiplied by -1 is going to give me -3x. I draw a line underneath and I subtract down. You might have recognised this technique from long division that you did at primary school. We got -4x and we're subtracting now for -3x, or -4x, subtract -3x. That's going to leave me now -1x. I bring the +1 down and write it like so. How many times does x go into -1x? Or what is -x divided by x? The answer is going to be -1 or -1. We write that like so and we multiply down. That's going to give me -x or -x, and then we're going to have +1. We subtract downwards and that will give me 0 plus 0, and clearly we have no other terms to bring down. This is our remainder here. So what we have is a remainder of 0. So let's just put that there. Remainder is equal to 0. What this is telling me is that x minus 1 is actually a factor of this cubic expression. And if we look at that, if we take now x minus 1, if we substituted 1 into here, 1 plus 2 minus 4 plus 1 is 0. Later on we will look at the factor and remainder theorem, but that gives me the confidence to know that I'm correct. So we could write this now as the following. This is the quotient, the expression that we get just here, which is a quadratic, as we've divided a cubic by a linear, is the quotient. So we write now this is the quotient, and the remainder is 0. That's nice and straightforward. So what we could do here is say now that x minus 1 multiplied by our quadratic of x squared plus 3x minus 1, and using the identity symbol gives us now the cubic of x cubed plus 2x squared minus 4x plus 1. And that now is the product, which means multiply, the product of a linear and a quadratic factor, which gives us a cubic. So that is polynomial long division. You're probably looking at it thinking, wow, lots to take on board. The first time you see it, it's quite daunting. As stated though, if you try enough, it will make sense. What I want to do at this stage is just highlight this right here. What we're now going to do is look at an alternative method, and that is setting up an identity and equating coefficients. A coefficient is simply the term that's in front of, for example, x squared or x. So the coefficient of the term in x here is 3. The coefficient of the term in x here is -4. And the way in which we do this is now to write an identity. So this is the second method, polynomial long division, and the next one is going to be writing an identity. What I know is that I've got a linear factor of x minus 1. And if I multiply that by some quadratic factor, ax squared plus bx plus c, and potentially, and I'm going to put this in to begin with, plus some remainder, this will give us now the cubic expression that we have in the question. That makes perfect sense as we've just done this backwards. So essentially what I'm going to get is this, but we're using the alternative approach. So what I'll have then is the x cubed plus 2x squared minus 4x plus 1. At this moment in time, I'm not going to include this plus r because we know that there is no remainder. If we didn't know that, we would assume that we needed to add the remainder. So at this stage, all I'm going to do is simply now equate the coefficients by expanding the right hand side. I know a linear multiplied by a quadratic gives me a cubic. If we look at the terms that are going to give me now a term in x cubed, it's going to be the x multiplied by the ax squared. So if I just write here x cubed, what we're going to have is simply a. Now that must be equal to the x cubed term over here, which is going to be 1. Now if we look at the terms in x squared, and I'll do this with a different colour, what we'll have now is the -1 multiplied by a, and also we will have the 1x multiplied by the plus bx. So if I write this on a different line, the x squared terms on the left hand side of the identity are going to give me -a, and then we're going to have now plus b. That's going to give me a term in x squared. Now what do we know that that's going to give us? Well, we've got over here the x squared is going to be 2. So I can simply write that in. From here, we can already see that a is equal to 1. From here, a is equal to 1, so I can write that down here. If I use this information here, what we can see now is that minus a, or negative a, which is -1, plus b must be equal to 2. From this equation, adding 1 to both sides, we can see that b is equal to 3. All we need to do now is find the value of c. The easiest way to do this is simply by considering the constant. So the term independent of x is going to be -1 multiplied by c. Every other term will give us something with an x in. So what I'm going to write here is that the constant, so if we constant, let's get the spelling correct. Over here, what we're going to have now is the following. -c will be equal to the constant over here, which is going to be +1. So from here, we can see now that this is going to give us that c is equal to -1. So that is done. Now you're probably thinking, what about the remainder? In the next example, I will do that. But all it means is setting up an equation to show that r is actually going to be equal to 0 in this case. So if we look at this, all we're going to do is put this back together. So we're going to have x minus 1 multiplied by ax squared plus bx plus c. Well, a is 1, so we just write x squared, plus bx, well, b is 3, plus 3x, plus c, well, that's -1, and that is what we get. So this right here is going to be our quotient. And we know that the remainder is 0. If you think about this now, think logically what I could do here. I could simply divide both sides by this x minus 1 factor, which would give us that. And that's exactly what we've done. Now if we go back to here, that's what we've got here. We've got now our value here, which is the divisor, multiplied by the quotient, gives us the original expression of a dividend. So that's another way of doing it. I actually prefer this method. Certainly if you've got where the constants are defined in terms of p's or q's. So for example, instead of 3x, we might have px, for example. So that is how we do it. That's polynomial long division, first one, and this is using an identity to equate coefficients. So let's have a go at another one. So next one we're going to look at question number 4. Find the quotient and remainder when x to the 4th plus 3x cubed plus x squared minus 2x plus 1 is divided by x minus 2. We're dividing a quartic by a linear, which will give us a cubic. So if you want your m and n, this power here is 4, so m would be 4, n is 1, so the resulting value, or the resulting expression, the quotient, will be a cubic term. Just looking along, we've got no gaps, x to the 4th, x to the 1st, x to the 3rd, x squared, x to the 1st, and x to the 0. So we don't need a placeholder. We're asked for the quotient and remainder. If you're only asked for the remainder, we would use the remainder theorem, which we're going to learn later. So let's look at the two different approaches. Polynomial long division, which is the first method, and then we will look at setting up an identity and equating coefficients. So let's go ahead and do that. So what we'll have is the following. So this one right here, we will have now x minus 2. Then we'll have now x to the 4th plus 3x cubed. Then we'll have plus x squared minus 2x plus 1. So no placeholders are required. We can of course divide this as the degree is 4 and the degree is 1. So again, I take my linear factor and I say to myself, how many times is x going to x to the 4th? Or, more intuitively, what is x to the 4th divided by x? The answer is x cubed. We start forming our quotient. We multiply down. X cubed by x gives us the x to the 4th, which we were expecting. Remember, these terms should be the same as when we subtract them. It will be 0. Multiplying down, we're now going to have minus or negative 2x cubed. We draw a line underneath and we subtract. We've got now 3x cubed, subtract negative 2x cubed, that will give me plus 5x cubed. I'm now going to bring down the plus 1x squared. Next question, x is into 5x cubed. Well, that's going to go plus 5x squared times, or if you like, what's 5x cubed divided by x? And the answer is 5x squared. Multiplying down, we're going to get now plus 5x cubed. Then we're going to have now minus 10x squared. We subtract downwards, 0 plus 11x squared. I'm subtracting 1x squared, take 10x squared is going to give, so I take negative 10x squared, is going to give plus 11x squared. We now bring down the negative 2x. And we say to ourselves, x is into 11x squared, or what is 11x squared over x? And the answer is plus 11x. We multiply down, and we're going to get, as expected, the plus 11x squared, minus 11x multiplied by negative 2, and that will give us negative 22x. We subtract down, and we end up with plus 20x. Bringing the 1 down, we're going to get plus 1. That's simply bringing the 1 down. And then we go back. X is into 20x is going to be plus 20. We multiply down, that's going to give us plus 20x, and then we're going to get now minus 40. So minus 40 on there. Subtracting down, we're going to have 0, and then we're going to have plus 41. This right here is the remainder. Often you'll see the remainder written now over the divisor. So we could say that this is going to be 41 or plus 41 over x minus 2. So plus 41 over x minus 2. We could write it now as the following. So if we wanted to now find the quotient, this right here is a quotient, x cubed plus 5x squared plus 11x plus 20. The remainder is 41, and we could write this now as the following. If we wanted, we could write, then let's just write it here, x to the fourth plus 3x cubed plus x squared minus 2x plus 1 divided by x minus 2 gives us now the identity of the x cubed plus 5x squared plus 11x plus 20 plus now the remainder, which is going to be 41, so plus 41 over the original divisor, which was x minus 2. So that's how we could express that. So that's the quotient, that is the remainder. If you just ask the remainder, it's 41. If you're not asked for the quotient as stated earlier, you will simply use the factor, or in this particular case, the remainder theorem to do that. And you would simply evaluate f of 2. You would put 2 through this function here, if we call this f of x, and find f of 2. That would give us what the remainder was. Okay, let's look at that particular example again and look at equating coefficients where we introduce the identity and also I'm going to have a remainder. So on this particular one, we would say now that x minus 2 multiplied by some cubic term. Now if we consider here, we've got a linear and we've got a quartic. That's a linear multiplied by a cubic will give us a quartic. So we'll have ax cubed plus, let's make that a 3, plus bx squared plus cx plus d plus some remainder will be now the equal to the x to the fourth plus 3x cubed minus 2x plus 1. So what we're going to do here is simply go ahead and equate coefficients. You might prefer the other method, you might think it's slightly easier. So if we look at terms in x to the fourth over on the left hand side, that will simply give us a. So we can say that a must be equal to 1. If we look at cubic terms, so terms now in x to the third, we're going to have minus 2a, so minus 2a, and then we're going to have plus b, and that will be equal now to the 3. So what we've got here is the 3, so from here we can say that that will be equal to 3. Now, we already know from this that a is equal to 1, so minus 2 lots of 1 is going to give us now the negative 2, plus the b is equal to 3. So we can see that b is going to be equal to 5. So a is equal to 1, b is going to be equal now to 5. So we found out that from the first 2 bits of information. If we now look at terms in x squared, then what we'll have, terms in x squared. On the left hand side, we're going to have cx squared, so I can write c. Then we're going to have minus 2b, and that will be equal now on here. If we look, let's just put that, we've got plus x squared, just miss that off. Let's go ahead and put that in, that's quite important. And again, you can see that this is not fraught with danger, but it's easy to miss terms out. So plus x squared minus 2x plus 1. So we've got now this is going to be equal to 1. That's the term in x squared, so I write that this is 1. So we can say c minus 2 lots of b, and that b here is 5, so minus 10 is equal to 1. So we can see that c is going to be equal now to the value here, which is going to be 11. So that's what we have, and we just keep going. So on the next one, we're going to look at terms in x. If we look at terms in x, we're going to have now minus 2, so that's minus 2cx, and then we're going to have plus d, and that will be equal now to negative 2 over here. So negative 2, and from here we can see now that c is going to be 11, so we have negative 22 plus d is equal to negative 2. So from this we can add that d is equal to 20. Okay, now if we look at the constants here, so the constants, and I'll just put constant for c, c for constant, negative 2d, so negative 2d, then we're going to have plus r is going to be equal to 1. So we know that d is 20, so this is going to give us negative 40 plus r is equal to 1, so r is going to be equal to 41. So all we got to do is write that r is equal to 41, and we can see now that these coefficients give us exactly what we were expecting. So we're going to have x cubed, a is 1, plus 5x squared plus 11x plus 20. This right here is the quotient. The remainder, r, is going to be now on here 41. The remainder, let's just, instead of writing r, let's write remainder. So remainder is 41. So if we go back now, this is exactly the expression that we had in the last particular one. So that is a way of equating coefficients. There are again alternative approaches. As you can see, this one was quite long-winded, and you might want to argue that it's easier to do it the other way. I would say if we were dividing this by, for example, 3x plus 2, it would probably be easier to equate coefficients. So that is an alternative method. Either way round, we get a quotient of x cubed plus 5x squared plus 11x plus 20 and a remainder of 41. Do remember though to check what you're doing. As you saw, I made the mistake of not putting this in, but luckily I got to that stage and altered it. So there's a basic introduction to polynomial division. In the next video, the example we'll look at is going to be slightly harder. Hopefully that's given you two different approaches, and you can decide which one you think is more efficient or effective for any given example. As you can see, it's probably easier doing the long division method rather than equating coefficients, but just practice the method. Once you've done a few, it should make sense.